on number, what is it, 19? Yeah, number 19. It would help for your intuition, or rather for your way of thinking about this problem, if you didn't remember how we did 17 or 16 or 15, because you might just get kind of mixed up in the methods. Because there are many ways to do these problems, but the particular method that I found to do this one is that you have 5 cards, right? And the way of choosing 5 different numbers, right? Remember your set, like your straights, right? We'll call them S, right? Out of this giant subset of 52, choose 5, right? We're gonna do that again by doing 13, choose 5, right? So we're gonna do 13, choose 5, right? But remember, what are the criteria that we have to fill? What is the probability that a 5-card poker hand contains cards of 5 different kinds, right? That's where the 5 in 13 choose 5 comes from. And does not contain a flush or a straight. So how many of these in here contain a flush or a straight? Well, we could kind of count it, right? If we look at some examples, right, of 13 choose 5. What's an example of 13 choose 5? 1, 3, 2, 4, 5. Right? That's an example of a 5-card poker hand of 5 different kinds, right? But for all of these different combinations, we also have 1, 2, 3, 4, 5, right? And then we have 2, 3, 4, 5, 6, and we have all of these straights here from 1 to 10, I believe. Yeah, so all the way down to 10, Jack, Queen, King, Ace, right? And so there's 10 straights that we can't count, right? Because we don't want to include a flush or a straight. So we have to do 13 choose 5 minus 10, right? And this comes out to, what's 13 choose 5? It's let me calculate it really fast. It's 1,287, and you should calculate that just for your own double checking, right? 12, so you get 1277, right? And so this is the way to choose 5 different cards. 5 different cards minus straights, right? And so we didn't really account for flushes, right? And so for these 1277, right, we have to now multiply this by ranks, right? Because we only got 5 different cards minus the few straights, but we haven't accounted for any of the possibilities and of colors, right? So we have a pretty small pool of things here, and we are missing a whole huge bunch of different color combinations, right? If you could imagine a straight as a box for a second, right? Then there's red boxes, or there's diamond colored boxes, there's heart colored boxes, right? For each box there's a diamond colored box, a heart colored box, a spade colored box, and a club colored box, right? So there's going to be a whole bunch, right, of combinations of this set here, right? So we have to do this set, which is 1277, times something, right? We'll use brackets to do times, right? And so what is this going to be in the bracket here? Well, that's going to be the ways to choose these 1277 by color, right? And so for each of these chosen, each of these cards, each of these 1277 different sets, in each of these sets, there's 5 cards chosen, and the way to get the suits, or to account for all the suits, is 4 choose 1, right? We've done this before. 4 choose 1 for every single card that we choose, right? for every card we choose, and then for every card we choose, that card we choose comes from the set of 5, which comes from the set of 1277, right? It gets kind of confusing. And so what's 4 choose 1 times 5? It's just 4 to the 5th, which is 1024, right? And so this is the set of 1277, taken a whole bunch of different ways. You know, if you can imagine 1277 times 1024, right? That's a fairly large number. But before we multiply by 1024, right, and get this huge number here, we actually have to subtract a tiny bit off of this huge number, because that's going to be the number of flushes. So we want to subtract just a little bit from this 1024. So let's do that really fast. Let's subtract the number of flushes, right? Because we don't want to choose a flush, right? And there's just a few flushes in these possibilities, right? There's the right, for the 5 different numbers, right? If you get 2, 3, 5, 4, 7, right? How many of these different flushes can you get? Well, for every way, there are 4 ways to get a flush, right? You can get diamond, or you get heart, or you get club, or you get spade, right? So, in each of these 1024 ways, right, 4 result in a flush. And this is going to seem counterintuitive. 1024 minus 4. Okay? There's 1024 different combinations, and 4 of 1000, there's 1024 combinations of 1277, and for every 4 there for every single one of these 1277 there's 4 flushes. Sorry, that's a bad way to put it. I'll try to think of another way to put it. But basically, you're gonna do 1020 times 1277, and that is going to get you 1,302,540. And if somebody can think of a better way to phrase why you subtract 4 from 1024, feel free. Basically, let's try to think of a way. The problem's over. This is out of C of 52, choose 5. And the reason why I think you're going to subtract 4, and let me conjecture for a minute here, is because 1024 is a subset, right? Here's your 52, choose 5, right? Here's your set of 5 or 1277, right? Right, and then you've got this other set of here for C of 52, choose 5, right? We want to do this is rather, it's not like this. I'm conjecturing that it's like this: 52, choose 5, right, and then you've got some subset. This is 1277, right? And then some subset of that is 1024, right? 24, right? And I believe that when you counted the 1277, right? This is obviously not to scale, but I believe when you counted the 1277. Of the 1024 ways, 4 result in a flush, right? You only can have 4 flushes, and I feel like you would have a lot more flushes there. So there's 1020 ways of choosing the suits without forming a flush. Okay, so here's the only way that I can think of it, really. And this may or may not help some people, but try to bear with me, right? 1024 times 1277 is going to be like 5,000 more than 1,024 or 1,020 times 1277, right? The accounting for flushes, right? Just by subtracting 4 accounts for not accounting for flushes. You know that loses you 5,000 different combinations, right? So if it loses you 5,000 different combinations, then subtracting 4 is a very significant decrease, right? And so I think it was a kind of a trick, right, that somebody figured out that at least I don't fully understand, but at least we can see now that it actually accounts for a large thing. You go, I was thinking, wow, -4, that's not many flushes in it, is it? But really, it's 5,000 of them, more or less. So that's maybe one way to think about it.